And we are back again. And the last thing that we want to do is we want to learn how to find the x and y intercepts of a quadratic function. And we can do that whether the function is written in standard form or vertex form. And you can see here that we're going to focus on standard form first. And in the next video, we'll find the x and y intercepts of this exact same function written in vertex form. Okay, so remember the x-intercept is the point at which the graph of the function crosses the x-axis. And remember, we have parabolas, right? So some of our functions will have two x-intercepts. But maybe you could imagine if I shift this parabola up far enough, it's going to have 0 x-intercepts. So some of them have 0 x-intercepts. And some still may touch the x-axis, and in those cases we'll have 1 x-intercept. So we could have anywhere between 0 and 2 x-intercepts. Right? So I'm going to find my x-intercepts on the left-hand side of the page. Now, no matter what, because the graph of a quadratic function is a parabola, we're going to have exactly one y-intercept. So we will always have a y-intercept. We may have 0, 1, or 2 x-intercepts, but we will always have exactly one y-intercept. Okay, and we'll find our y-intercept over here on the right-hand side of the page. Now remember, whenever I cross the x-axis, the y-coordinate is 0. So in order to find the x-intercepts, or x-intercept, if there is one, we're going to replace y with a 0, and remember y is represented with this f of x. So then I'm placing a 0 on the left-hand side where f of x is. So 0 equals 2x squared plus 12x plus 11. Our x-intercepts, if they exist, are going to be given by the solutions of this equation here. Now, we can solve this equation one of three ways. We could try to factor it. That only works sometimes. We could choose to complete the square, right? That's one very valid method of solving an equation like this one. Or we could choose to use the quadratic formula. That's what I'll focus on. So the quadratic formula, if you remember, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we can use this formula, by the way, because what we have is a quadratic function. Since we have a quadratic function, we can use the quadratic formula. Now, in order to use the quadratic formula, we just take our a, b, and c from standard form there, and we fill them into the formula. So b is 12, so then we have negative 12 plus or minus the square root of 12 squared minus 4 times 2 times 11. And that's all over 2 times 2. So then to find our values for x that are going to satisfy this equation, we just simplify. So negative 12 plus or minus the square root of 12 squared is 144 minus 4 times 2 times 11 turns out to be 88. All over 2 times 2, which is 4. So we have negative 12 plus or minus the square root of this difference here is 56. All over 4. Okay, so these two values here, right, one value for the plus, one value for the minus, actually give us our x-intercepts, but it's good form to go ahead and simplify them, right? So let's simplify the square root of 56. So we'll simplify that radical. Now we can factor 56. We can write out the prime factorization. That would be 2 times 2 times 7. See, that's going to give us 28. And then if we throw in another 2 there, we'll have a 56, right? So 2 times 2 is 4, times 2 is 7, and times 2 again gives us a 56. And of course, that's all over 4. So we have a pair of factors here. Right, that 2 times 2. So this radical becomes the square root of 2 times 2 times the square root of 7 times 2. And of course, the square root of 2 times 2, well, that's just 2. So this is negative 12 plus or minus 2 on the square root of, and we multiply what's left, 14. Okay, so we simplified the radical. Now we can simplify the entire expression because each one of these terms here, so I have one term, negative 12, another term, 2 square root of 14, and then this term here at the bottom here is 4. Each one of these terms is divisible by 2, so we can reduce this entire fraction here, and it becomes negative 6 plus or minus the square root of 14 all over 2. And so just for clarity's sake, that's actually negative 6 plus the square root of 14 all over 2, and negative 6 minus the square root of 14 all over 2. So we have two x-intercepts, and we found them both. They're not rational numbers, but again, we have them both, and we found them by plugging our values for a, b, and c into the quadratic formula and simplifying. Now, if you found that to be a little bit challenging, that's okay. You're going to absolutely love the way that we find the y-intercept, because whenever we cross the y-axis, remember x is 0. So then to find the y-intercept, we look at our expression for f of x, and we replace all of the x's with a 0. In other words, we find f of 0. So f of 0 in this case is 2 times 0 squared plus 12 times 0 plus 11. And look at that. It is 11. So the y-intercept then is 0, 11. And we're done. You may have noticed that this constant term here actually matches that y coordinate there. That's always going to happen so long as you have your function written in quadratic form, right? Or I'm sorry, as long as you have your quadratic function written in standard form. See you in the next video.